The next level of complexity up from a two-step equation is an equation in which the variable appears on both sides. For example, we might have an equation that looks like this. 7x minus 2 equals 4x plus 13. Notice that we see an x on both sides of the equation. Remember that in solving an equation, our goal is to get an equation in the form x equals a number. That equation doesn't have x appearing on the right-hand side. So, in order to get our equation into that form, we need to get rid of the x term on one side. Usually we'll pick getting rid of the x term on the right side. It doesn't matter which side we choose. We just have to choose one. We'll usually choose the right side because it's easier. So, in our example, to get rid of the term 4x, we'll add negative 4x to both sides. Now, I'm going to write this out in detail in this example rather than using the shortcut, just to make sure that we can see what we're doing. So on the left, we'll have 7x plus negative 2 plus negative 4x. And on the right, we'll have 4x plus 13 plus negative 4x. Now we'll eliminate the parentheses. We'll combine the like terms. 7x and negative 4x are like terms, so we'll have 3x. And then there's nothing we can do with the negative 2. 4x and negative 4x are like terms, so we'll have 0x. And then there's nothing we can do with the 13. 0x is just 0. We don't need to write that term. And now we have the equation 3x plus negative 2 equals 13. Notice what we've done. This is now a two-step equation, which we'll solve like we would any other two-step equation. We'll get rid of the constant by adding 2 to both sides, and then we'll get rid of the coefficient by dividing both sides by 3. And we get the solution x equals 5. Now, did that really work? Is it really true that 7 times 5 minus 2, does it really equal 4 times 5 plus 13? Well, 7 times 5 minus 2 is 35 minus 2 is 33. 4 times 5 plus 13 is 20 plus 13 is 33. Yeah, those really are equal. That really is the solution. So this just adds essentially a third step to our process for solving two-step equations. So our first step now is, if there are variable terms on both sides, eliminate the variable term on one side. Our second step is, if there's a constant term with the variable term, eliminate it. And then our third step is, if there's a coefficient, eliminate it. In our first example, we did not use the shortcut for the additive property in writing that first step. Let's see another example where we do use the shortcut. Suppose we want to solve this equation. 5x plus 22 equals negative 2x plus 1. Our first step, we want to eliminate the x term on one side. We can pick whichever one we want, but I'll typically pick the one on the right. So I want to eliminate negative 2x. I want to do that by adding positive 2x on both sides. Note, I'm writing these terms underneath the like terms. They're each written under an x term because they are each an x term. So 5x plus 2x is 7x, leaving the plus 22 alone. Negative 2x plus 2x is 0x, leaving the plus 1 alone. This 0x term is just 0, so I'm going to not copy that. My next step is going to be to eliminate the plus 22 by adding negative 22 on both sides, or if you prefer, subtracting 22. Notice again, those are written underneath the like terms. 7x I'll leave alone. 22 plus negative 22 is 0. And 1 plus negative 22 is negative 21. Finally, I have this coefficient 7. To eliminate this coefficient, I can think of multiplying by 1/7 or dividing by 7. Right, dividing my left-hand side by 7 and my right-hand side by 7. Again, the 0 term doesn't do anything. The 7 cancels out, and I'm left with just x on the left. Negative 21 divided by 7 is negative 3. That's my solution. Whenever I've solved an equation like this, I should be in the habit of checking, so I'm going to do that now. I'll evaluate the left-hand side when x is 3. 5 times negative 3 is negative 15. Negative 15 plus 22 is positive 7. Negative 2 times negative 3 plus 1. Negative 2 times negative 3 is positive 6. Plus 1 is positive 7. Seeing that those are equal, x equals negative 3 really is my solution.